So now we have this example. A body of mass 0.1 kg, 0.1 kg is dropped from a height of 8 meters, okay, into a hard floor, okay. Then it bounces back again up to about 2 meters high. The same ball, 0.1 kg. Okay, calculate the change in momentum of the body in contact with the force, with the ground, with the floor for 0.01 second. Okay, so what's the force exerted on the body? So you have two questions here actually. Okay, first we have to calculate the change in momentum. How do you calculate change in momentum? But first, this has to do with vertical distance, not horizontal distance. So that means that takes us to the laws of motion. I just want to recap this. The laws of motion, they are actually three in number. V equals to U plus or minus GT squared. Sorry, GT. Then H equals to UT plus or minus half GT squared. And then the last one, V squared equals U squared plus or minus 2GH. So where V here is the final velocity, U is the initial velocity, G is acceleration due to gravity, and T is time. H is height, then U initial, then I think I've talked about all of that. All right, so that's V for final velocity, U for initial velocity, G for acceleration due to gravity, T for time, H is equals to height. All right, so I haven't recapped that. Then we're going to look at this. The first thing we're going to calculate for is the fact that at maximum height, just at the top of this, it is at rest. So just before it begins to drop down, it is at rest. So the initial velocity here is actually 0 meters per second. That means initially, before it started coming down, it was not moving. So U actually has to be 0. Then by the time it gets, just before it hits the ground, what is that velocity that it has attained while coming down? What is that? So that takes us to the formula. Now, so we have U. So we have to decide which of the formulas to use. We have U, which is 0. We have V, which we are looking for. We have height. So what are we, which of the formula are we supposed to use? You see this one? Now in this formula there is no height, so we can't use this. This is out of it. This, we have height, we have U, but we don't have V. And V is what we're looking for, so that's not, so this is this is the formula we're going to use. So using this formula, V squared equals U squared is 0, U is 0 squared, then plus, because it's coming down, it's in the same direction with gravity, then 2 times, they say G is equals to what, 10 meters per second, that's what they say, 10, then height is what, 8 meters, 8. So basically we are saying V squared is equal to 2 times 10 is 20 times 8 is actually 160. Okay, so take the roots of both sides. So this will cancel out this. So V now becomes square root of 160, and square root of 160 is about 12.65 meters per second. So calculated for V just before it hits the ground. Then let's now go and find. Now listen. Now, when it hits the ground, it takes a particular time to do that. Then it bounces up back again to get to its maximum height. Now, at this maximum height, I'm going to call this U1. this guy here is 0 because that's gotten to its maximum height. So that's just, anytime you project something, goes up, then stop, then come down. So that's what happening. So by the time it gets to 2 meters, it has exhausted its velocity and it's just at rest, just about to come down. Then that means it must have been coming up with a particular velocity. Let me call that u2. I don't know what it is. So that's what we're looking for, u2. Now in this question, now the same formula, we have 2 speed, v and u, whatever, and we have 2 as our height. Now which one is the initial, which one is the final? Now remember that it starts here before coming to this point at the top. So that means this is going to be our initial u, and this is going to be our final v. So using that same formula, v squared u squared, so you have v squared equals u squared plus or minus 2gh. Now we already said that our initial, because this is where it starts from the ground level, is u2. So initial is u2 squared. Then our final is at the top, and that's u1 squared. Then because it's going up, is against gravity. Gravity is downwards. So that means it's going to be negative minus 2, then gh. So what's our u1? Our u1 is 0, as we have seen here. Our u1 is actually 0. Okay, u1 is 0 squared, and u2 is what we're looking for, u2 squared, minus 2, g is 10, our height is 2 meters. You can see the height, 2 meters. So basically I'm going to take this to this side, and that gives me minus u2 squared equals minus 2 times 2 is 4, 4 times 10 is 40. Okay, good. So I'm going to divide both sides by minus. So minus cancels out minus, minus cancels out minus. So I have u2 squared equals 40. So I'm taking the roots of both sides. This cancels this. So I'm left with u2 becomes square root of 40 is actually 6.32 meters per second. So that means just before it starts to go up back, it's actually 6.32 meters per second. Then as it goes up, it begins to reduce until it gets to 0. Okay, now we've gotten our u and our v. Then we have to find, the question says that find the change in momentum in the body. Change in momentum. Now remember that change in momentum has also to do with impact. But first, let's find the change in momentum. That's the question. Let's try and find change in momentum. Change in momentum is actually mv. That's mv minus u. Okay, that is change in momentum. Okay, good. Now, as this body, the same mass, 0.1, 0.1. Now, it starts. Then from here, it changes from this v. We've gotten this v earlier. We got this v to be 12.65 meters per second. So we can see that there's a change in this, and there's a change to this when there is an impact, as you can see. Now, if you notice, because they are going in opposite direction. This was initially coming down, and then this was going up. So they are in opposite direction. Now, since they're in opposite direction, then they have to subtract each other. That means this one has to be the negative of this. Okay. Then this guy here, since it's going up, has to be the negative of this guy here. So I remember that change in momentum is this. Now, so that means the mass is actually 0.1. Then the final velocity. So that means you have 12 point, since it's changing, you have 12.65 minus, now because this is in opposite direction of this, it has to be the negative, minus 6.32. Okay, good. And so we have 0.1 into 12.65 plus 6.32, and that gives us 0.1 into 1.89. Sorry, no, that's 18.89. So multiply that by 0.1, your final answer has to be 1.89 kilogram meters per second. Now the question says that you should also find force. What is the force exerted on the body? And the time taken to do that is actually 0.1 second. Okay, good. Remember that F is actually equals to change in momentum divided by t, according to the second law of motion. So that F now becomes, change in momentum is actually 1.89, then the time of impact is actually 0.1 second, and so that gives us 18.9 newtons. So that's approximately 19 newtons. So the force is actually 19 newtons. So we got that. And so that's the answer to this question. So it looks kind of rough, but then because the question is actually very complicated. All right, good.